we'll come back to Helper Dad. First, let's briefly explain what a classifier is, which is an algorithm that categorizes data into predefined classes. We will be using scikitlearn, also known as sklearn, a popular Python library for machine learning, and we will cover installing the library, preparing data, choosing a classifier, training the classifier, evaluating the classifier, and making predictions. This tutorial is targeted towards beginners with basic Python knowledge. To begin, you'll need to install scikitlearn. You can do this using pip with the command pip install scikitlearn. To verify the installation, simply import sklearn in your Python environment using the command import sklearn. Now, let's prepare the data, which is a crucial step. We'll choose a simple dataset, like the iris dataset, which is readily available within sklearn.datasets. Load the iris dataset using these commands. From sklearn.datasets import load_iris followed by iris equals load_iris. It's important to understand the dataset structure, which includes features, the data itself, and labels, the target variable we want to predict. Next, split the data into training and testing sets using from sklearn.model_selection import train_test_split, and then x_train, x_test, y_train, y_test equals train_test_split, iris.data, iris.target, test_size equals 0.3. The test_size parameter determines the proportion of data used for testing, in this case, 30%. The training set is used to train the model, while the testing set is used to evaluate its performance. Now, let's choose a classifier. There are various types of classifiers available, but we'll select logistic regression for its simplicity. This can be found within sklearn.linear_model. To use it, import the chosen classifier with the command from sklearn.linear_model import logistic regression. Now it's time to train the classifier. First, create an instance of the classifier using model equals logistic regression, solver equals liblinear, multi_class equals OVR. Here, we've specified the solver and multi_class parameters, which define how the equation will be solved and how multiple classes will be handled. Then, train the classifier using the training data with the command model.fit, x_train, y_train. After training, it's essential to evaluate the classifier. Start by predicting the labels for the test data with y_pred equals model.predict, x_test. Then, calculate the accuracy of the model using these commands. From sklearn.metrics import accuracy_score, then accuracy equals accuracy_score, y_test, y_pred, and finally print f. Accuracy, accuracy. Accuracy represents the proportion of correctly classified instances. Finally, let's make predictions using the trained model on new data. For example, let's predict the class of a new flower using the command new_data equals 5.1, 3.5, 1.4, 0.2, and then prediction equals model.predict new_data. Print the prediction using print f. Prediction, prediction. The output will be the predicted class for the new data point. To summarize, we've covered the steps involved in building a simple classifier using scikitlearn, from installing the library to making predictions. We encourage you to explore different classifiers and datasets to expand your knowledge. There are many online resources available for learning more about scikitlearn. Now, try building your own classifier with a different dataset to solidify your understanding. Thanks for watching. See you next time on Helper Dad.